We'll do 2i after 2 double I. We'll do the proofs first, then we'll talk about non-permissible values. Again, take out your scrap piece of paper. Prove A and prove B. You guys have done really well. So in A, for the proof, again, rewrite the question. Draw the line. If you use the strategy of changing from sine to cos, this is cos theta over sine theta. I'm going to draw a thicker line over 1 over sine theta. Fraction divided by a fraction, multiply by the reciprocal. If you're multiplying and two factors are the same, they can simplify. That only works if you're multiplying, and that only works if they're completely identical. They are in this case. We just get cos theta, so our left side is equal to our right side. Done. Do I have enough room? I think I do. I'm going to do B on this side. Again, rewrite your question. This question is almost completely in sine and cos already. The left-hand side is just cos. The only thing I have on my right side that I can change to sine or cos would be the secant. So I will change that 1 over cos theta, and then 1 plus 1 over cos theta. I have fractions inside of fractions. I want to get a common denominator. I'm going to multiply this 1 by cos over cos. And I saw this on a couple of examples. You know that the top has to stay the same, and you're just working on the bottom, so you start ignoring the top. But one thing they're checking in a proof is every line that you write has to be equal to the line above it. So if you decide not to write the 1 plus cos because you're just adding the bottom and just writing the bottom, you will get deducted for not having your work equal all the way through. So again, keeping it clean, keeping it organized. I'm trying to model that I've left some space here, left some space here. I've made my main dividing lines longer. Cos theta plus 1 over cos theta. Can you see that I now have a fraction divided by a fraction? My top fraction is actually, oh, I don't want to go to blue so much. Here we go. My top fraction is 1 plus cos theta all over 1. My bottom fraction, if I multiply by the reciprocal, is cos theta over 1 plus cos theta. Now, we're multiplying right here. I can't cancel out this cos and this cos because this one has adding. This groups this together as a factor. This one has adding. That groups that together as a factor. Whenever you have adding and subtracting, you can add brackets to say that's grouped together. Do I have any factors that are identical? Yes. 1 plus cos theta and 1 plus cos theta are identical. We're multiplying. Those factors are identical. They can simplify. And what are we left with? Just cos theta. So our left side is equal to our right side. So that's part 2, the proof part. Part 1 in this question said, determine the non-permissible values of theta. Okay? Non-permissible values of theta, we've had a little bit of this in chapter 6. This is what's not allowed. So far, what have we talked about not being allowed in mathematics? You can't take the square root of a negative. Do we have any square roots here? No. So that's not even going to be an issue. What other thing are you not allowed to do? You're not allowed to divide by 0. Are we ever dividing in these questions? Yes. Okay? We are dividing in a number of places. So I'll take out my highlighter again. Can you see that you're dividing here? Can you see that you're dividing here? You are dividing here. When we change it to sine and cos, what are we dividing by? We're dividing by sine. So for our non-permissible values for A, sine of theta can't equal 0. Does sine ever equal 0? Non-permissible values. Yes, that's on your pie plate. When is sine equal to 0? At 0, at pi, at 2 pi. That's once around the circle. Here, I'll just write. These are your answers from 0 to 2 pi, but the question is asking to list all the non-permissible values. That would be a general solution. So we would say that theta cannot equal, I can combine all of those together by writing k pi. Example 2 is a little bit more complicated. Okay? Determine the non-permissible values. Where are you dividing? Okay. You are dividing by cos. You are dividing by 1 plus cos. So if we look through all the places that we're dividing by cos, we're also divided by 1 plus cos. So in B, cos of theta can't equal 0, and 1 plus cos of theta can't equal 0. Cos of theta can't equal 0. And 1 plus cos of theta can't equal 0. When is cos equal to 0? So these non-permissible values. At pi over 2 and 3 pi over 2. And on this other side, if you move over the 1, cos of theta can't equal -1. That means theta can't equal pi. How do we write all of our solutions? Again, because these solutions here, they're from 0 to 2 pi. So if I want to write all the things theta can't write, I take all those solutions from 0 and 2 pi. And add 2k pi. It's much easier to see your non-permissible values after you've done your proof, because you have to check through your proof, where are all the places I've divided? And if I check where all the places I've divided, then I can find out what can't happen. In the second one, cos theta can't be 0, and 1 plus cos theta can't be 0. Okay, questions for practice on this one are 4, 8II, just the proof part, 9II, just the proof part, and 11.